Okay, we're going to look at another proof by induction question. This time this is one which has two different terms, which both have a power of n, a little bit different to the last example. But the same principle still applies, so it's proof by induction. So we are going to carry out the 3 steps required for the proof. So step 1, we are going to show it's true for n equals 1. Plug in n equals 1, we get 5 plus 2 times 11 gives us 27. 27 divided by 3 is 9. That is an element of the positive integers. Therefore, it's true for n equals 1. Okay, nice and straightforward. Step 2. This step, I break it down into 3 sub-steps. So we state the assumption. So in this case, I'm going to assume that 5 to the k plus 2 times 11 to the k is divisible by 3 for some positive integer k. I will show that 5 to the k plus 1 plus 2 times 11 to the k plus 1 is divisible by 3. Okay, and I will show that this is true using this assumption. But 5 to the k plus 1 plus 2 times 11 to the k plus 1 can be written as 5 times 5 to the k plus 22 times 11 to the k. Okay, now what I'm trying to do is work through some algebra to get this in so that I can use my assumption. So I need to somehow use this expression. So I'm going to actually write this 5 here as a 2 plus a 3 times 5 to the k. Plus, and I'm going to write this as a 4 plus an 18 times 11 to the k. Okay, so I've written the 5 as a 2 plus 3, and I've written the 22 as a 4 plus 18. Okay, now the reason I've done that is so that when I multiply out these brackets, I will have 2 5 to the k's and 4 11 to the k's. That's essentially 2 of my assumptions. I'm left with then 3 times 5 to the k and an 18 times 11 to the k, both of which are divisible by 3 because 3 is divisible by 3 and 18 is divisible by 3. So that's 2 into 5 to the k plus 2 times 11 to the k plus 3 times 5 to the k plus 6 times 11 to the k. Now that, by my assumption, is divisible by 3. So that is divisible by 3. And 3 there is clearly multiplying. So this is divisible by 3. And k is a positive integer, therefore this expression here is a positive integer. Take any positive integer and multiply it by 3, it then must be a multiple of 3. So therefore it's divisible by 3. And because that's divisible by 3 and that's divisible by 3, then this whole thing here must be divisible by 3. Finally, step 3, just to summarise what we've done. So I have shown it's true for n equals 1, that's step 1. By assuming it's true for n equals k, I've shown it's true for n equals k plus 1, that's this bit here. Therefore, it must be true for all positive integers n.